bisecting the line. Suppose we have a line AB, and we want to find the point halfway between A and B, called M. So M equals MB, and M is on the line. This is called the midpoint. And to find the midpoint, what we're going to do is we're going to make two circles. We center one at A and one at B. Two circles need to be big enough that they intersect at 2 points. They need to have the same radius. So what we do is we take one circle centered at A with radius AB, and one circle centered at B with radius AB as well. We draw the two circles, and we see that they intersect at 2 points. We draw the line segment connecting these 2 points, and it intersects AB at exactly 1 point, M, the midpoint. So we've just bisected the line. Next, we want to learn how to construct a perpendicular to a line segment AB at A. That means we want the line that meets AB at right angles and passes through A. There's only one line like that, and we'll see how to make it. First, we extend the line segment AB, and we draw a small circle around A that meets the line at 2 points. We'll draw circles, just like in the midpoint construction, from these 2 points, and because they were the intersection of the small circle, they're both the same distance from A, and A is their midpoint. We see that the line drawn through their intersection of 2 points does indeed meet at A, and you'll notice that line is perpendicular, so that's the line we want. Next, we're going to find the center of a circle. We take a random port around the circle, and we're going to make the perpendicular bisector. That's the perpendicular line passing through the midpoint. So we do the same construction with two circles around the endpoints of the line, and we see that the line we get passing through the intersections will indeed go through the center of the circle. It's, of course, the diameter. While it's inside the circle, that's the longest line. We do the same thing with another chord, and we get another diameter, and the only place two diameters can intersect is the center of a circle. So we found it. Finally, we'll go on to the main construction, the decagon. We start with a circle, and we can find its center A because we saw in the last section that we can find the center of a circle. What we'd like to do is we'd like to make a 10-sided polygon, all 10 sides the same. That's called a regular decagon. And we're going to start by drawing the line AB, where A is the center and B is any point on the circle. We make a perpendicular to AB at A, which we saw in the first section. We mark D, where that meets the circle at either one of the 2 points. We'll pick the bottom. We can construct the midpoint between A and D, as we saw in the very first section. Then we draw a circle with center E and radius B. That's going to intersect up at the top, as we see in the pink circle here at F. We draw another circle with center A going out all the way to F, and that will meet at C. C is the important point we wanted, and so we can forget everything except C. Next, we draw a circle centered at C with radius AC, and we'll see that that'll meet at 2 points. We're going to pick G, and now we can forget all about C. All we really needed was the length BG. Now we make a series of circles around the outside. Now, since these are circles, BG will be the same length as B to our unnamed point at the top here. We draw the series of circles, and we get a series of lines at the intersections of these circles, all of which are the same length. And we see that it works out to exactly 10 circles. If you're doing this by hand, you may not have your circles match up exactly at the end, or you may even not get the right number of circles. You have to be pretty precise. Now we'll drop these circles, and we're just interested in 10 points we got. We hook them all up with line segments, and we see that we get a regular decagon. There you go. Two final notes. First of all, you can get a regular pentagon out of this if you just connect every other point. You can try it at home. And the second point is that although I've given a construction for decagon here, What's much more interesting in math is to understand why we get a decagon if we follow this. And so for full explanation, check Euclid's Elements. You can find it at your library or free online.